So very good morning to very good afternoon to all of you. So today we'll see the first experiment, that is 2 is to 4 decoder. So all we know that 2 is to 4 decoder means it has got two inputs and 2 to the power 2, that is 4 outputs will be there. So as it has been shown here, so two inputs A and B are there. 2 is to 4 binary decoder, 4 outputs are represented by Q0, Q1, Q2, Q3 like that. So the actual truth table, as we know that, so when both A and B are 0, 0, output Q0 will be selected and remaining all our outputs will be 0. Means only one output will be selected. So similarly, when A is 0, B is 1, output Q1 will be selected, and when A is 1, B is 0, output Q2 will be selected, and when both are 1, last output will be selected. So the logic circuit, basic logic circuit is very simple. Based on the K map, we can get these logical equations. So we need two inverters and four AND gates. And if you connect them like this, we'll get the 2 is to 4 decoder. That is a basic decoder logic circuit, 2 is to 4 decoder logic circuit. But for the syllabus, so he quoted we have to implement everything using NAND gate. So this is the 2 is to 4 decoder using NAND gate only. Means that we have to implement two inverters using two NAND gates only. So if you apply the same input to the NAND gate, you will get the inverted version of the input. Similarly, you will get means here NAND gate is acting like an inverter by applying same input to it, that we are getting A bar here. Similarly, by applying the same input B to the second NAND gate, we are getting the B bar output. So in this way, we are using the NAND gate as inverter here. Similarly, so what we want the output here at each of the Q0, Q1, so that is going to decide how we have to use the NAND gate. So NAND gate, the first NAND gate you can see here. So this one you can see it is coming from A bar. This is A bar is there. So more thing is clear here. So better you can see here. This is A bar, it is coming here. A bar, and it's another input we are getting from the B bar. So both the inputs to the first NAND gate here is A bar and B bar. A bar and A bar dot B bar whole bar. A bar dot B bar. So here output what we are getting, A bar dot B bar. It is a NAND gate whole bar. If you apply the De Morgan's law, what we are getting, A plus B. So here the output what you are getting, A plus B only. Means if you use only one NAND gate, you are getting A plus B. But what we want, A bar and B bar. Once you get A plus B, and if you apply the same input again, both the inputs as A plus B and A plus B here, and get NAND gate, what you're getting, A plus B bar. If you apply the De Morgan's law to the A plus B bar, what you're getting, A bar B bar only. Means by using by connecting one inverter to each of these NAND gates, we are getting back our outputs A bar B bar, A bar B, A B bar, and A B like this. So let us see how to do the coding here. So this one we are using structural coding. Okay. So we have to call structural coding. Let us try to understand how to do this one. We have to implement this 2 to 4 decoder only by using the NAND gate. Okay. So now I will call all these NAND gates by some naming here sequentially. So N1. So sorry, N1 is there here. Okay. N1 NAND gate, N2 NAND gate, N3, N4, N5, N6, N7, N8, N9, N10. Totally 10 NAND gates I want. Okay. So how many wires I want? So in order to, wires are nothing but intermediate connecting wires which are we are using to generate intermediate signals. Now we can see A input is a basic, two inputs are A and B are there. Okay. Again the same input I am using here to give it twice as input to the N1 to get my inverted version of A. Okay. So this output A bar I will call it as a W of 0. You can see here W of 0. So I'll be taking it as a vector here 5 down to 0 because how many wires I have defined here? Totally 6 wires. 0 to 5 means 6 wires. Similarly, not B you are getting W1 I will call. So this will be these namings I will be giving A bar as W of 0, B bar as W of 1 because when I am connecting this A bar as input to one of the input to N3, so that will be taken as W of 0. Okay. Similarly, when I will be connecting this B bar as one of the input to the NAND gate 5, then it will be connected with the help of the wire W of 1. Means I am indicating A bar with the wire W of 0 and B bar with the wire W of n. Means I can access A bar with the help of W of 0 and B bar with the help of wire W of 1, like that. Okay. So like that, if you do the interconnections here, for example, let us see how to do the interconnections here. First, we'll have to define the inputs and outputs in the Verilog code. Module decoder, some name you can give here. So the inputs are A and B, and outputs I have taken Z0 to Z3. Four outputs are there. That is a four outputs, 2 is to 4 decoder. So two inputs A and B are there, and output, either if you want, you can define them individually Z0 to Z3 like four outputs, or you can call it as a output vector like 3 down to 0. Just now we have defined, no, here for wire 6 wires. I have represented this one in the form of a vector, or you can individually write like this. Now this part is important, guys. NAND, so NAND N1 here. So N1 input ಏನೇನದಾವ ಅದನ್ನ ಬರೀಬೇಕು. Okay, so inputs are A and A. So two inputs are there, A and A, same output we are giving, and output, what is the first variable? Output you are getting W of 0. Similarly, N2, how you are writing? NAND N2 means N2 is acting like a NAND. This component is acting like a NAND gate, and its output is going to be W of 1 with the same input B and B, like this. So next you can see, guys, N3 is there. I am defining this N3 as a NAND, another NAND component, for which it is able to provide the output W of 2 with the input. What are the inputs here? W of 0, W of 1. How you are writing? You can see here. So this input, it is coming from here, W of 0, that is indicating our A bar, and another input, it is coming from W of 1, that is indicating our B bar. Okay, so these are the inputs here, W of 0, W of 1, I have written here two inputs, and output, what it is generating? It is generating the output W of 2. Okay, so actually what you are applying here, actually A bar and B bar you are applying. So once you apply A bar and B bar as input, output what you are getting? A bar dot B bar whole bar. After applying De Morgan's law, what you will get? A plus B you are getting here. Okay, but we want this one. We want A bar B bar. Okay, so in order to get A bar B bar from A plus B, again you have to apply the inverter. We will get the, because A plus B whole bar, after applying De Morgan's law, we will get A bar B bar. Okay, so this how we will define the N3 here. Similarly, N4 you can see here. What is the output? W of 3, and inputs are going to be here. One of the input is going to be W of 0. For N4 you can see N4 is there here. W of 0 is coming here. It is okay for N4 component. W of 0 I have written here, and another input is directly coming from B here. Another input is directly coming from B here. Okay, so W of 0 and B I have written here, and output is going to be W of 3. Output is going to be W of 3. Similarly, you can define another N5 as a NAND component with its output W of 4, and its input is going to be A. One of the input is A, and another input is going to be W of 1. So like that, we have to define, I have written here N6 up to N10. Okay, this how we are going to provide the interconnection between all the NAND components here. Okay, this how it is called a structural way of coding, writing the code in a Verilog. Okay, so there are three modalities are there: behavioral flow, data flow, and structural flow. This is the structural flow. It is there. It is mentioned in the syllabus. That's why we covered this one. Okay. So now let us see how to do the simulation.